use z-scores to compare the given values. The tallest man, or the tallest living man at one time, had a height of 248 centimeters. The shortest living man at that time had a height of 58.7 centimeters. Heights of men at that time had a mean of 175.64 centimeters and a standard deviation of 6.97 centimeters. Which of these two men had the height that was more extreme? Okay, so first and foremost, a z-score or standard z-score or standardized value is the number of standard deviations that a given value x is above or below the mean. So we have our sample formula and our population formula. In this case, the given values are for all men at that time, not just the sample. So therefore, we're going to use the population z-score. So the first thing we're going to do is we're going to look at the tallest. So we're going to find out. We're going to abbreviate this. We're going to be z and then subscript t to represent the tallest. Okay, and then we're going to use the formula to find out what that z-score is going to be. Okay, so what do we need to know for this problem? So for the tallest man, and I'm abbreviating it as t, we know that the value of x is 248 centimeters. We know that the mean, or the population mean, was given to be 175.64. And we also know that the standard deviation is 6.97. And so now we're going to plug it into our formula. So we have x, which is 248. And then we're going to subtract the mean of 175.64. And then we're going to divide it by the standard deviation of 6.97. So let's go ahead and do that. So we have 248 minus 175.64. And then we're going to divide that by 6.97. And then we always round z-scores to two decimal places. So we're going to get 10.38. So the value for that is 10.38. Okay. Now let's go ahead and find the z-score for the shortest man. So again, we're going to get the x value for the shortest man, and if you look at the top here, the shortest living man at that time was 58.7 centimeters. Okay, and again, we know that the mean is 175.64 with a standard deviation of 6.97. So we're going to call this z subscript s to represent the z-score for the shortest man. And again, the formula for that is x minus the population mean divided by the population standard deviation. So the x value is 58.7, and then we're subtracting the mean of 175.64, and then dividing that by the standard deviation to 6.97. So let's go ahead and find that. So we take 58.7 minus 175.64, and then divide that by 6.97, and then we're going to round that to two decimal places. So it's going to give us negative 16.78. So we get negative 16.78. Okay, now the last question is asking us which of these two men had the height that was more extreme. So the way we would describe this is the following. Since the z-score for the tallest man is z, which is equal to 10.38, and the z-score for the shortest man is negative 16.78, the shortest man had the height that was more extreme because this is farther away from the mean. So therefore, this would be our answer. Since the z-score for the tallest man, z is equal to 10.38, and the z-score for the shortest man is negative 16.78, the shortest man had the height that was more extreme.